nature's battleground. Animals fight for their survival. Out of this conflict, an extraordinary weapon has evolved. One that forever changed the rules of engagement between predators and prey. It is one of evolution's greatest achievements, the eye. The animal kingdom encompasses millions of species, and more than 95% of them share a common trait, the power of sight. Eyes are everywhere, but look closer. No two species see the world in quite the same way.
Animals have a tremendous variety of eyes. We see different appearances of eyes, we see different sizes of eyes, we see different configurations of eyes, and this is because animals have different lifestyles.
Among the sharpest eyes in the animal kingdom are those belonging to birds of prey. Searching high in the sky for tiny prey demands remarkable vision. And birds of prey have evolved eyes that are second to none. This eagle spies its prey from more than a mile away. Even while diving at speeds of 200 miles per hour, it tracks its target with deadly precision. The secret to the eagle's success? The anatomy of its eye. In most cases, the larger the animal's eyes, the sharper its vision. And the eyes of the eagle are huge. Eagles are 100 pounds lighter than we are, but their eye weighs the same as ours. Size is just for starters. The back of our eye has 200,000 light-capturing cells per square millimeter. The eagle's has 1 million, providing 5 times the image resolution. Its lens is flatter and placed farther away from the retina than ours. The result? A gaze as sharp as a telescope, magnifying its helpless prey to 3 times what our own eyes can see. What force drives the development of such a remarkable innovation? Evolution. The sparks of evolution are tiny, random genetic changes.
Every once in a while, there's a little mistake made when the DNA is passed on from generation to generation. And those mistakes are called mutations. And sometimes the mistakes cause problems, other times they create new opportunities.
Mutations that boost survival and reproduction are favored by natural selection. Species that can't adapt disappear. 99% of all species have gone extinct over time. The survivors are equipped with mutations that have given rise to uniquely powerful traits. The eagle has evolved one of the most powerful eyes in nature, but it is just one of the many different types of eyes that have evolved over time.
Animal eyes are an excellent example of convergent evolution. All the eyes on different animals across the planet today did not evolve from the same ancestral eye. In fact, eyes have evolved numerous times in different lineages.
Remarkably, evolution has used the same basic genes to build the eyes of creatures as profoundly different as flies, squid, and humans. Research points to an origin for these building blocks of all vision 600 million years ago. The Earth's oceans are calm. There are no monstrous predators to contend with, no creatures armed and ready for combat. Sea life is simple. Animals come in 2 sizes, small and extra small. They're soft, with little protection, and they have one speed, slow. But it is here that one group of creatures took a dramatic step toward vision. These pioneers are long extinct, But one of the oldest living lineages of animals still swimming in today's oceans provide a peek into the past. Jellyfish. Biologists Alex Goodell and Chad Widmer of the Monterey Bay Aquarium are on the hunt for a test subject.
Go get him.
One that can give them insight into the roots of vision.
Oh, yeah, that's a nice looking one right there, yeah.
This is Polyorchis, more commonly known as the bell jelly. The anatomy of this delicate creature is about as simple as animals get. It has no skeleton, no heart, and no brain, just a loose network of nerves. But it has a crucial innovation that its survival depends on. A ring of small dark spots line its base. Light-sensitive organs called eye spots. We can only imagine what these most basic of eyes can see.
Vision for them is very different than for us because we are able to form images quite well and they aren't. So it's kind of more of a blurry world for them than for us.
Scientists don't know why the distant ancestors of modern jellies evolved light-sensing cells when they did. But Goodell can show how they have helped jellyfish survive for 600 million years. She has designed a simple experiment showing how bell jellies use light detection to their advantage.
I'm interested in seeing if different animals that don't form images can see different colors if they respond to different wavelengths of light.
Goodell subjects the jelly to light waves that it would find in its natural environment. First, she hits the jellyfish with a dose of green light. On cue, its body goes limp and drifts to the bottom of the tank.
See, the tentacles are getting longer.
Oh, yeah, yeah. So you can definitely see when they're relaxing. Tentacles extend, they pulse less frequently.
The green light usually makes them appear to relax. They usually will drop down to the bottom and their tentacles will extend and their bell pulse rates will decrease.
Why does green light put the jelly so at ease? It's the wavelength of its home turf, the ocean floor.
They usually spend most of their time on the bottom where they would naturally be getting a lot of green light. They find most of their food on the bottom, so they're used to being in this type of light.
Goodell then switches things up. Purple light fills the tank. Suddenly, the jelly pulses wildly.
When I flip on the purple light, the jelly seemed to go into this escape response. Their tentacles shorten up and their bell pulse rate increases.
It's a reaction akin to us fleeing from a fire. To the jelly, purple light means one thing. Injury, or even death, might be imminent. The reason is simple.
Short wavelength light, like purple or ultraviolet, blue lights, it's actually higher energy, and it can be very damaging for organisms that are transparent. So a lot of transparent animals rise up in the water column in the evening and hang out on top at night. And then in the morning, as the sun's coming up, they migrate back down.
Light triggering action. A simple vision system, to be sure. But it's helped jellyfish survive over 500 million years as they find food and evade predators. But the eye's evolution would not stop there. More than 500 million years ago, the calm waters are to be overrun with a new breed of creatures. Eyes are about to get a powerful upgrade and unleash an evolutionary arms race that will forever change life on Earth. The dawn of the Cambrian period, 544 million years ago. The animal kingdom is undergoing a time of transition. Early animals were simple, passive creatures, drifting through the current or anchored to the sea floor. But over the course of 50 million years, a lot is going to change.